Hi, in this video, I'm going to explain the basics of recursion. Now, I recorded the video a while back, and in the video, I defined my own function sum, which shadows or hides the built-in sum function. So I should have named it something else. Other than that, though, here it goes. Hello. In this video, we are going to be talking about the topic of recursion. And in case you're wondering what that funny cartoon is, it's a cartoon of Winnie and Tigger, Winnie the Pooh and Tigger, if you know who they are. And it's an interesting cartoon that I found online that's kind of showing an infinite recursion. So anyway, right off the bat, I am actually going to ask you to write a function using what we have learned before. And this function is just a sum function, so it takes a single integer, n, and it should return the sum of adding 1 and 2 and 3 all the way to and including n. So I know we've learned to do something like that when we talk about loops, but we didn't do it in a function. And yes, I know if we name the function sum, is going to hide the built-in function sum, but it's okay for this short exercise. So pause the video, just quickly write this function and make sure you test it and get it right. Okay, assuming that you've done that, I am going to actually try to do this myself here. So n, sum of n, so I'm going to have an accumulator, right? That to accumulate all the numbers, accumulator I start at 0 because I haven't done anything yet. So, and then I'm going to say for I in the range all the way up to n, I'm going to accumulate the I into the accumulator, right? And then I'm going to return the accumulator at the end. I'm just going to test it with a very simple number, which is, sorry, I'm going to call the function. I'm going to just test it with a very small one. So 1 plus 2 plus 3 should give us 6. But it gives us a 3. So what's wrong? Well, hopefully you didn't make the same mistake as I did. But remember, range gives us numbers from 0, 1, 2, all the way up to, but not including n. Okay, so if I say n is 3, basically I'm adding the numbers 0, 1, and 2. And that's why the sum that it gives me is only 3, right, instead of 6. So what I would have to do is do plus 1 here. Right, so that now it gives us the right sum. Okay, so hopefully you got it right. And now, so what the type of function that we just wrote, it's what's called an iterative function. So the characteristic of an iterative function is that it uses loops. In this case, a for loop, to repeat some code to achieve what they want to do. Okay, so iterative use loops, and it works, and if you get it right, it works fine. But what could possibly go wrong? Well, one thing we just saw is that, yeah, I use n instead of n plus 1, right? Some other things that might go wrong is, I call the accumulator S in the slide, but something that can potentially go wrong is maybe I forgot to initialize S or the accumulator, or maybe I will initialize it to something that's incorrect. I mean, maybe I type it as 1. I don't know why, but it could conceivably happen. And when you talk about loops, especially when you talk to non-programmers at first, maybe you yourself, when you talk about loops, when you run into loop for the first time, it's not an exactly intuitive concept, right? And then other things that can go wrong, especially with the accumulator, is that, maybe we could forget to add the I to the accumulator. Maybe I do a S equal to I instead of S plus equal to I, right? Or if the loop is more complex, like the code that will repeat is more complicated. This one is very simple, but in something that's more complicated, we could maybe inside the loop inadvertently change S to something that's incorrect, right? So a number of things can actually go wrong. But having said all that, in Python, this iterative function is actually is less likely to go wrong than maybe some other languages. So if you have done C++ plus Java, the for loop in those languages are shall I say, much worse or syntactically than the Python for loop, right? So, but even in Python, as I pointed out, a number of things can potentially go wrong, right? Even in something that is just a few lines. So that serves as a motivation for writing recursive functions. Okay, what a recursive function is, very simply, a function that calls itself to repeat the code. So rather than using loops, such as for loops, to repeat code, recursive function calls itself to repeat code. So let's see how that's done. Let's rewrite the sum function using recursion. Okay, and for this sum recursive function, and practically for most recursive functions, for every recursive functions, there are really three questions that we always ask about these functions. The first question in case of sum is that we want to know what is the value of n that makes this function a trivial function. That, again, it's something. What is the value of n that we can pass to sum such that it's so simple we can kind of see the answer right away? Okay, that's what I mean by trivial. So think for a moment, what is the simplest possible n for sum? Well, hopefully you come up with the same answer that I do, and most right. That is the sum of n. I'm sorry, the sum of 0 gives us a 0. That is really simple, right? There's nothing simpler than that. So that's the first question we'll ask. What is the simplest case? Okay. And then the second question we ask is, what is an easier or simpler version of sum that we can solve? Okay, and the motivation for looking for solving an easier or simpler version of sum is such that we can actually make a little progress towards an eventual solution, right? So what is a simpler version of sum that we can solve? A simpler version of sum of n would be, let's make n a little smaller, right? Let's try to solve the problem of sum of n minus 1. So sum of n minus 1 is a simpler version of sum of n, right? So that's the second question. That's kind of the recursive case, okay? The third question is, all right, assuming somehow we have the answer to sum n minus 1, then how would the answer to that, the recursive case, help us to solve the problem we currently have, which is we want sum of n? Okay, so what that is sum of n is really n itself plus the sum of n minus 1, right? So I hope that kind of makes sense, right? Because yeah, let's say we're trying to solve sum of 3, right? Then sum of 3 is really equal to 3 plus the sum of 2. Okay. So when we put all of the answer to all the 3 questions together, then here's what we get. The sum of n is 0 if n is 0. Otherwise, sum of n equals to n plus the sum of n minus 1. That's recursion, right? And some of you might recognize something like this when you do math. So this is really just a definition of a math formula. And once we decompose things into math, it's great because math is really nice. It's a beautiful language. And it's not necessarily simple, but in this case, it's kind of simple too. But math is just beautiful and elegant. So anyway, so now that we have this kind of a mathematical equation for for sum, how do we turn that into Python? Well, let's give that a try. I'm gonna redefine sum again. So remember what we said. If n is 0, what is the sum? Well, it's just 0. Otherwise, sum of n equal to n plus sum of n minus 1. Okay, I'm going to print it out again, sum of 3. And assuming I do everything right, this is, it give me the same answer, right? And we can check other things like, I think the example we use when we're doing the loop is 100. So if we do 100, sum of 100 is 5,050. Okay, so hope that kind of makes sense. So in kind of summary, let's look at this function that we've done. We said that loop was unintuitive. Well, so this one, unlike the iterative function, it didn't have any loop, right? We also said that when we have an accumulator, the accumulator kind of keeps states around, so we could set it to the wrong value and do things we didn't intend to do with it and all that. So we don't have any variable, which is great. So without variable, we also eliminated all the things that can go wrong with the variable. And then finally, we didn't have to worry about using range. And is it range, is it range n or is it range n plus 1? So isn't that nice? So it is a rather simple and a beautiful and elegant solution to the sum function.